You gotta love when you're doing a technical presentation and the first thing you have to do is troubleshoot your gear. Not that we've all been there. Thank you so much for attending. Um, just as the slide says, no code, no problem, we're going to talk about how we've made things a bit easier to do some of the wonderful things you've heard about in the main sessions with regards to Skylight Analytics. But first, I actually want to give you guys a little bit of a view of where does Accedian, now part of Cisco, fit into the overall Cisco family, and why are we here? You've heard about this downstairs with regards to crosswork and how it provides some additional information into crosswork and a means of actually getting performance within the network. But we're actually part of a master plan that Cisco has been working on for years. And if you look at the trend of the acquisitions that have been made over the last few years, you start seeing something happening a little bit towards the right here that is more along the lines of observability and information. And when we really look at that from the perspective of where Cisco is going, right? We have the best networking out there. Phenomenal security tools. Splunk's augmenting that. That is part of that strategy as well. Collaboration, gotta love it. But observability is an area where we can bring it all together to really provide to our customers the tools they need to make the decisions that the network deserves. So that's how Accedian became part of the Cisco family, was to help augment the input into the observability. And it's really about being able to visualize the network performance, but do it in a very proactive manner. Finding issues before they're issues. Catching gremlins that you would otherwise spend weeks, months, and sometimes years chasing. Being able to actually give our customers the tools to truly commit to the SLAs that they have signed up for. I remember sitting with a customer and asking their sales team how they dealt with the RFPs they were receiving from the providers out there, from the operators out there, as far as the SLAs go. When they're asking you for a certain availability, when they're asking you for a certain latency, a certain loss, how do you make sure that the network and the services you're going to set up for them actually meet them? An answer I got from one was very eye-opening. We go back and look at the last RFPs we've responded to and see if we signed up for it there. I said, okay, and how do you guys make sure you're meeting these SLAs? Well, if they don't call and complain, we're good. Versus, hey, what if you actually were able to provide your customers with the visibility of how your network is doing? Oh, we can do that. So the blind spots are not just in the network. Many times they're with what our customers have to work with. It's blind spots of information. When we look at taking information from the network into a visualization scenario, it's everything from 5G, private or otherwise, all the way over to cloud performance. And you have to be able to look at things from a segment perspective, but you also have to be able to look at things from a holistic perspective. And as you can imagine, there are probably quite a few different data sources and types of data that come in. And no, as much as we would like to say it, they are not all generated by Accedian, Skylight, Cisco probes. There's actually data in the network that comes from the network. Being able to take that data and correlate it together and actually look at information that may seem very disparate. I mean, what does CPU utilization have to do with packet loss? Have to do with latency? What does my class of service marking have to do with whether or not I have a delay change? You may look at it and say, nothing. They're different pieces of information. And that's why many times it's different groups within the customer that are looking at these different pieces of information. So not only is there two different groups looking at it, those two groups many times don't even talk to each other. So now how can we enable them to not only see them, but even open up the lines of communication? I'm going to give you an example of a customer who has over 100 unique users logging into their instance of analytics every single day. And they're spread across over a dozen different groups. And each of them has a different reason why they log in, a different thing they are looking for. Part of us joining the Cisco family was how do we actually treat Cisco data as native data? How do we enable and make it easy for our partners, easy for our customers, easy for our services team to ingest the data from Cisco devices? And that's really what today's session is about. It's about talking how we've actually made it so that Cisco data coming from XR devices can be treated as native. And we've done that by using a telemetry collector. Now, how many of you have used Telegraph? Great. I'm done. Who wants to come up and give the presentation? All right. Full disclosure, it's built on a Telegraph agent. So if you've used that in the past, then you're going to be very familiar with what you're going to be able to do. What we've done, however, is we've made it such a way that it automatically gets the information that's being sent from the XR devices, translates it into a data set that's natively recognizable by analytics. So it takes a lot of that legwork out of it. The dictionaries are already in the system. Some of the important data we want to see. Interface data. What's the utilization coming across those different interfaces? Types of packet. Information on both physical and virtual interfaces. My environment. CPU memory. Utilization. Metrics that start coming together to tell a story, as I said earlier. Policies. Being able to look down to a policy level. And actually looking at native Y1731 ETH-OAM performance metrics. Both for packet loss, delay, jitter. Also being able to look at IPSLA. What it means is we can facilitate our customers to take information that's already contained within the network they have without having to add additional probes. And you only add those where it makes sense and where it's needed. And doing so very efficiently and very quickly. What it really means is being able to take delay from any source. Jitter from any source. Loss from any source, and then combining it with information such as utilization, such as CPU, such as memory. And you start really being able to build trends, build baselines. So what the analytics does is machine learning allows it to start building dynamic baselines. Because it's not about what happens right now. That's very important. But I'd say that pretty much any tool out there, including the guy sitting behind the main screen or around the phone, can tell you when something's broken. When it breaks, everyone knows, right? Outage. Ooh, hey, fiber cut. Wow, good job. So glad you figured that out for me. But how do we see something that's going to be a failure? How do we start seeing a trend that's actually demonstrating that the optics on the SFP pluggable are starting to go bad? You may start seeing some pretty consistent and small amounts of packet loss on that particular interface. And it may not show up on looking at things from an hourly or a daily or a weekly perspective. And we shouldn't have to go look at things from a hourly, weekly, daily, minute perspective. The solution should do that for you. The system should do that for you. And it should tell you, hey, by the way, this has changed from my normal. When we design a network, we have a design threshold for latency, design threshold for packet loss, so on and so forth. As long as it's below my design threshold, as long as it's below my SLA, I'm good, right? Yeah. But if something starts changing from that normal, you want to know about that before it goes above that SLA threshold. That's what I meant by the proactivity. It's not just looking at it, it's doing something with what you're looking at. So I'm going to do a quick little demo here. And I'm going to show you how we install and configure the telemetry collector. And the demo guides don't have to be good to me because it's a video, and if not, I can describe the whole process to you. It's actually quite simple. And the purpose of the demo is to actually show you just how simple it is. And everything is available on the currently still Accedian docs.io site, which will soon be Cisco as it's converted over. And it literally has the description of exactly how to install it. It's got the sample code you can copy and paste and just change the parameters that you need. But as we look at it, let's think about some of the prerequisites. And this is what I really want to highlight to you guys is, there you go. Okay, let's try that again. Sorry, demo gods. I know I said something I shouldn't have said. That's what happens when your video actually has the same background. We need an analytics tenant. We need a data collector. We need a small compute environment. Okay? We need some CPU, and each one can process 195,000 metrics in 10 seconds. So this isn't about days. This is about getting information at a very, very timely manner. Postman is a tool we're going to use. We're going to create a telemetry collector, and then we're going to get its secrets and do it. Everything is available on Accedian, docs.accedian.io. The user guide, sample files, you can all go there and get it and use it. If you don't have access to a demo environment, work with us. We can make sure you have access to the demo environment. You can literally copy and paste directly from the site with the information. Just keep in mind that you're going to want to configure the header information to be relevant to the system that you're actually putting it into. You're going to need to put your collector / Roadrunner IP in there so that it actually knows, hey, where am I getting information from? Okay? You can just put it right into Postman, or whatever your favorite tool is. We've actually named it here for the dev days. You can pick whatever name would make sense for that scenario or that system that you're using. Okay. We're going to copy out some JSON information so that we can use it a little bit later. We go into analytics, and we're going to see, hey, I have a telemetry collector, but it's unregistered. Well, let's go ahead and generate some secrets so we can actually register it. At this point, analytics knows, hey, there's a telemetry collector out there, but it's not allowed to do anything. So what we're going to do now is we're going to actually go ahead and compose it. We're going to go ahead and put in its secrets so we can authenticate in and actually now be part of the environment. Again, going back, your information is all there. You can continually use it as a reference or use your favorite little notepad to put stuff into. When we deploy the collector itself, okay, we're just basically going to compose it. You can use whatever text editor you want. Use Nano in this case. Pick whatever your favorite is. As we've put in the secrets, we ask it to compose, and now it's running. Now you have to figure out where am I getting this data from. So what you're going to have to actually do is you're going to have to go in. I'm a little ahead here. Okay. Collector's up and running. Now, where are we getting our data from? So we're going to go into the Cisco XR device, and we're basically going to tell it, hey, here's a destination group, a sensor group if you actually want to put it together, and then a subscription group to say, hey, this is the information I actually want to send out. The step that actually takes now this data from the device via the telemetry collector and into analytics. All of the configuration is available for you. I keep coming back to this because effectively it's all available for you guys at your fingertips, okay? Once we've deployed, once we've validated that we've configured our XR router to send it to the right place, we see that it's gotten resolved, so we're in good shape. Well, now we're going to go back into analytics and say, hey, I've imported this, but what now data do I actually want to use? Just because we have that list of data doesn't mean we can't not use some of it if we don't want to. So we go and we find our Cisco telemetry interface, and now we say, okay, I want to have these particular metrics that are coming in. For those watching the screen, you saw that there was a heck of a lot of other metrics that were there, okay? And I'm actually going to skip this and come back to it. This is a small section of what we can automatically bring in to analytics. But you're probably all going through your head and saying, I can think of a lot of other metrics that would make sense. There's probably a few other things that I would actually want to bring in. You're not alone. We have customers that have said, I want the information from all of my different SD-WAN devices to be going into analytics because I'm using 4 different SD-WAN vendors, and every single one of them gives me a slightly different result when I look at KPIs. And I can't make sense of these apples and oranges, and I want to give them to my customer, and when my customer calls me up, I don't understand what they're asking me because I got to make sure exactly which solution set is that particular branch of that customer using. So what we did there is we were able to actually take all of the information from the various managers and orchestrators from these SD-WAN devices. We were able to normalize that data to make sense. Sometimes it was a simple unit of measure conversion. Other times we had to do a little bit more conditioning. And then put all of that into dashboards and views that now actually show them a holistic performance across the board. And then they're providing their customers with a dashboard. And it's the same dashboard regardless of the SD-WAN vendor that's in the background. You heard downstairs about using a KPI from our power consumption, from optical readings, from other information. All of that is also being done in a very similar manner of time series being brought in via not the telemetry collector. There we're using open metrics to bring it in. We're bringing in information from third-party non-Cisco devices in order to be able to correlate across from a multi-vendor perspective. So while I've shown you today how to easily bring in information from the XR routers, what I want you to take away as well is we're not limited to that. So if we need to bring in information beyond that, our friends at CX can help out with that. They can make sure we ingest whatever we need to ingest and then be able to put it together in a way that makes sense. Multiple data devices, multi-vendor, is actually, for those Cisconians and sellers in here, a big advantage for Cisco. I want to sell everything to them. I want them to buy it all from me. Yes, Real world is very, very, very few customers have a single vendor scenario. Being able to offer them a solution set that not only gives visibility into the performance of the network that is made up of Cisco devices, but also extending that out into the network that's not, allows them to truly see just how good the Cisco performance is as compared to others. Allows them to really get a complete view of what it is. And as you saw with regards to Crosswork, with regards to NSO, also enables those tool sets to make much better decisions. And that AI session was extremely interesting because the better the data going in, the better the decisions going out. It's intelligent input, intelligent output. This is enabled by us being able to bring all of this together. We talked about commercials. I'm going to end on that. Should have been my last slide. I want to give you guys an idea of what an object is. So as you're sizing this up, okay, well, what does this mean? Each telemetry object consumes a telemetry license. Analytics is made up of object licenses. A PM session, a TWAMP session is an object license. A utilization session is an object license. Now that TWAMP session has 80 some odd metrics in it, but it's an object license. Well, each of the telemetry objects, whether it's router, environment, whether it's policy interface, each one of those is an object. So each one of those would consume a license. That allows you to be able to dimension out what am I going to need as far as the overall number of sensors. I keep trying to call it an agent. The overall number of collectors, okay? And also allows you to dimension out how big is this going to be from a cost perspective for our customers. Okay, any questions? Yes, sir.
So you were demonstrating this API, the legacy REST API. Could you do the same thing using the RESTconf API?
Yes.
Follow-on question is then, why didn't you? This is an NSO and model-driven crowd, so that would be more impressive.
This was less about, you're talking about with regards to getting the data out?
It's about being able to ingest this information and control this thing. But it maybe...
Well, because we're using an agent framework we've already built. So when we've already built a framework to bring in data from the various probes, and all we did here was leverage the exact same framework. So from a development perspective, we didn't have to recreate the wheel to do it. We literally leveraged the same thing because the agents we have out there, actually Henrik talked about some of them, whether it's DNS, whether it's FTP, whether it's even our TWAMP agent. We just created this as another component within that same family. So everything going upstream to analytics is the same. It hasn't changed. So we weren't going to create something new just for this new collector. Okay. Any other questions? Yes, you go.
So in case the customer already has or has plans to have Crosswork CNC and Crosswork data collector, the CDG, how does this telemetry collector fit into that scenario? Is the CDG and the job collectors in CNC going to replace the telemetry collector for Accedian, or are they going to coexist?
They would coexist.
One to the side to the other.
So if you look at CDG that's bringing in data from the various parts of the network, we have a collector that would sit alongside of that. That collector, which was formerly known as Roadrunner, will actually receive the information in from the agents, from the various probes, and also in from the telemetry collector.
Okay.
And in turn, that's sending information up to Crosswork.
Okay, clear.
The back first.
Talking about that collector within the IETF, there is a new NMOB group that is looking at the Yang Kafka model, where they have a kind of Yang library to have the semantics always correctly. Is this something that is on the roadmap of Accedian also?
I'm going to defer to Henrik on that one.
Yeah, so right now in our plan, we are looking at various standards nothing planned right now. So it's something we're on the
It's
horizon for, yeah.
was from 6 months ago, so
Yeah.
don't expect it.
Yeah, but it's good to hear it being mentioned because it's on their own horizon.
Okay, thank you.
There was another question up here. Ted.
Yeah, I was just wondering if you support dial-in on telemetry or if it's only in dial-out.
Well, this effectively SDK is effectively a. We support both. When we're doing open metrics, we're going and getting that information. So we're going and requesting that information out. We've set the telemetry collector to receive that information because iOS XR can actually export it out. So we'll support both. The plan is to do as much more of having the information coming in as possible because at that point you're relying and allowing the device sending it to manage that part of it. But most of the implementations I showed above from SD-WAN, so on and so forth, was us actually going out and getting that information, whether we're doing it via your most basic of SNMP to, subscribing to a bus.
Thank you.
You're welcome. Okay.
Any other questions?
Tried keeping it under time. Thank you very much. Appreciate it, everybody.
Thank you.